All right, so we're going to talk about absolute value inequalities. Let's look at the first case. The first case, our symbol is a greater than symbol. So we are going to look at the interval notation. So guys, go ahead. I want you to talk with your group. What do you think this will look like? The absolute value of x has to be greater than or equal to 7. What do you think this has to look like? Ready, go. How are you going to graph it? Okay, so what we have here is x, the absolute value of x is greater than or equal to 7. I'm going to do two cases. I'm going to do one where it's exactly the same, and I'm going to do another one where I change the sign and change the sign of the number. Okay, so guys, let's look. What's a number that's greater than 7? 8. So that means the absolute value of 8 is greater than or equal to 7. That's true. What's another number that's bigger than 7? 9. Okay, absolute value of 9 is also greater than or equal to 7. So that means all the numbers that are greater than 7 will make this true. Does that part make sense? Okay, now let's look at the other part. What if I put absolute value of negative 8? Is that greater than or equal to 7? What's the absolute value of negative 8? 8. And that's greater than or equal to 7. So guys, that means the numbers on the left side of negative 7 also work. Okay? Let me give you another example so this concept can sink in. The absolute value of negative 9 is what? 9. Is that greater than or equal to 7? Yes, so that means negative 9 also works. So the numbers on the left-hand side of negative 7 also work. Yes, you have to put both. Okay, so let's talk about the interval notation of this. We always start on the left-hand side. Let me highlight this for you. On the left-hand side, we have an arrow pointing to what? It's pointing to the left, which is which direction? Negative infinity. So that will be a parenthesis. Now, the next item, we move left to right, just like we read a book, is right here. Where is that? Negative 7. So our next number will be negative 7. That will be a bracket because this is a closed circle. Now, this space right here where we cannot be, I'm just going to put the union symbol. You can think of it as an and. Okay, the next significant thing is right here at 7. And there's an arrow right here pointing to infinity. So that is how you do the interval notation. Okay, now let's look at how the graph will be different whenever you have a less than or equal to sign. Okay, there's going to be two cases again. One case, I'm going to keep it exactly the same. The other one, I'm going to change this symbol and change that sign. So keep, change, change. Okay, so let's graph what this looks like. The numbers less than or equal to 4. This is 4. The numbers less than 4 are going this direction. The next one, x is greater than or equal to negative 4. Here's negative 4. Greater than or equal to negative 4 is this way. So we're creating a bar. Oh. They're connected. Okay? So notice when you have a less than or equal to, you're going to have a bar. When you have a greater than or equal to, they will face opposite directions. Okay? Those are your two different types you'll see on the number line. Okay, now let's talk a little bit about this so we can understand the graph that we just drew. Can you guys pick a random number on this bar that I just drew? 0? Okay. Is the absolute value of 0 less than or equal to 4? Nice. Okay. Pick another number. -2. Is the absolute value of -2 less than or equal to 4? Yep, so those numbers on that line work. Anything outside of that bar will not work. Make sense? Okay, so that's how you graph these. Okay, so let's go ahead and answer this question here. What does this mean? So inequalities are also, let me see, are also compound, meaning there's two of them. These inequalities are also compound inequalities, meaning there's more than one. Okay. Oh, let's write the interval here. The interval goes from -4 to +4. Oh. That's your interval, from -4 to +4. All right. Let's go ahead and do some examples. We're going to learn how to solve inequalities that have these symbols, greater than or less than symbols. Okay, so let's look at our first example, and I have the steps right here. The first step is to always isolate the absolute value symbol. So for number 2, it's already isolated. You guys see that? Okay, it's already isolated. They did the work for us. So let's go to step 2, create 2 cases. And they say use the KISS method, which means keep it, switch, switch. So I'll show you what that means. Your first case, you're going to keep it exactly the same. Keep it. Your other case, I'll have 2v minus 3. I'm going to switch the symbol, switch the sign. That's what that means. Keep it, switch, switch. That's your 2 cases. Now from here, we're just going to go ahead and solve. Okay, this is what we practiced yesterday. We're going to go ahead and solve these. So I can add 3. So I'll get 2v is less than, what is this? 22. Then divide both sides by 2. Am I dividing by a negative? No, so I don't have to flip the sign. I did not divide by a -2. I divided by a +2. So no signs will be flipped. This is my first inequality. My next one, I'm going to add 3 to this side. What will I get? Good, -16. And then I'm going to divide by 2. Did I divide by a negative? That means our sign will not change. We did not divide by a negative number. We divided by a +2. So the sign will not change. Okay, so guys, let's go ahead and graph this. The first one says b is less than 11. So everyone go to 11. What kind of dot am I going to use? An open dot. And which way will I face? Left, because it says less than. Okay. The next one, this says b is greater than -8. So let's go to -8. What kind of circle? Open. And that's a greater than symbol. So I'm going to face to the right. Oh, look, guys, these lines are touching. These are going to create a bar. So that means you can be either bigger than -8, but smaller than 11. That's what this says. Case 2. I'll show you. So the interval for this is -8 to 11. All right, let's do another example. Okay, next example. This is number 3. It's already isolated. It's already isolated. So we're going to create our 2 cases. First case, I'm going to have -5 plus k over 3 is greater than or equal to 1. The first case just stays the same, okay? Your other case, I'll write it over here. You change the sign and you change this sign. Change the symbol, change the sign. Those are our two cases. Now we're going to solve and then graph it. All right, guys, what should I do first? Yep, we're going to add 5. So I am left with k divided by 3 is greater than or equal to 6. Now what do I do? Yes, multiply by 3. Those cancel. Multiply by 3. So what am I saying? K is greater than or equal to 18. Guys, did I multiply by a negative just now? No, I multiplied by a positive 3. That means my sign stays the same. You only change it if you multiply or divide by a negative. Okay, let's do this side. You're going to add 5. And let's see what we're left with. K divided by 3 is less than or equal to 4. We're going to multiply by a positive 3. That means our sign doesn't have to change. So K is less than or equal to 12. So I'm going to go ahead and graph this. Here's 18. I'm going to do a closed circle. Which direction do I face? To the right. This is a greater than symbol, a G for greater. So go to the right. Okay, this says K is less than 12, less than or equal to 12. So I'm going to put a closed circle at 12. And this says less than, so it's going to face that way. Okay, so interval notation. You always start on the left. So guys, right here is an arrow that's facing negative infinity. Next is right here at 12. That will be a closed bracket. Next is an 18. So we're going to put the and symbol, the union symbol, and put 18. Next is an arrow. That's infinity. Always read it left to right. All right. How do you guys feel about this? Easy, good, nice. Do y'all need one more example? Y'all got it? One more? Okay. I'm going to do a harder one for you guys. Flip over to page 12 or question 12. This one, they didn't do the first step for us. You have to isolate it. Okay, so let's practice isolating.
Is this the one where it's flipped where you don't do
Okay, so next one. We're going to add 9 first. So what am I left with, guys? $84, perfect. Okay, now I'm going to divide by 4. Can someone tell me what that will be? Thank you. Nine minus 3n is less than 21. Perfect. Okay, now it's isolated. This is now where I'm going to create my 2 cases. So now we're moving on to step 2, create 2 cases. One case will stay exactly the same. So I'm just going to write this again. 9 minus 3n is less than 21. The other case, I'm going to flip the sign and change this to a negative 21. Those are my 2 different cases. And then we solve. So I'm going to subtract 9. We have negative 3n is less than, what is this? 3. What is this? Okay, guys, did I divide by a negative? Yes, I divided by a -3 this time. That means the sign will flip. So this is now n is greater than -4. Okay, now I'm going to subtract 9 on this side. -3n is greater than -30. Divide by -3. Guys, I divided by a negative again. That means this sign will now be a less than symbol. Change the sign. -30 divided by -3 is a +10. So these are your two inequalities. Okay, I'm going to do open circles on these. Why am I doing open circles? Yes, it's not equal to. Okay, so I'm going to have an open circle at the -4 and an open circle at the 10. I want to be greater than -4, but smaller than 10. So it's going to create a bar. So my interval notation will be -4 to 10. You can be anything between -4 and 10, just not -4 or 10. Okay? It doesn't include -4 and 10, but anything in between.